In this section, we're going to be solving systems of equations. So, and what we're going to be looking for is we're not going to be looking for solutions for a particular, just one equation. We're actually going to search for a solution that works in two equations. And I mean, this method can be used for three equations with three unknowns, but we're going to stick with two equations and two unknowns. So you're going to be given two equations, and in this first example, cover up some of this wording here. All right, here, ultimately, I want to find a solution that works in this equation and it works in this equation both. Well, if I graph the solutions, well, let's just go through it. So we're going to graph the solutions, and then you'll be able to see, kind of what we're doing and the idea that we want. So how do you graph x plus y equals 5? Well, we have a couple of methods. It's not in the form y equals mx plus b. So we're not going to use that method. What I suggest you do is let's use the method of the x and y intercept. And the reason I'm going to do that for this first equation is because 1 goes into 5 times, and 1 goes into 5 times. So if these coefficients go in, both of these go into here without a fraction, then you can use the x and y intercept. All right, so let's start. We've got x plus y equals 5. To find the y-intercept, the x is 0. So it's going to hit at y equals 5. So I'm going to go to the y-axis, and I'm going to put a spot on, or a point on the 5, y equals 5. Now, to find the x-intercept where it hits the x-axis, the y is 0. So x plus 0 is just x. So it's going to hit at 5. It's going to hit the x-axis at 5. We have our 2 points, so we can connect them up. And again, I am graphing the solutions. This is a picture of the solutions. Any point on this line will work in that equation. Any point you choose, ordered pair. All right, we have another equation to graph. And again, this 1 does go into 1, and a negative 1 goes into 1 with no fractions. So I'm going to use the x and y intercept method. Let me flip this page over. Okay. Let's graph x minus y equals 1. Okay, so to find the y-intercept, x is 0. So we have a negative y equals 1. We'll divide by a negative 1 because we do want a positive 1 in front of the y. So y equals 1 divided by a negative 1 is a negative 1. So this one, and again, when you're graphing these with Pearson, is you'll press your line icon because you want a line, and you'll graph this one, but don't press save until after you graph the other one, because we want both graphs on the same. So you graph this one, and you go back up to the line icon and press it, and then graph the other one. So we're going to graph this second equation, y equals a negative 1. So we'll go to a negative 1. All right. To find out where it hits the x-axis, the y is 0. This y is 0. X minus 0. So x equals 1. That was easy. X is 1 and y is 0. So we go to 1 on the x-axis because x is 1. And we're going to connect those points. It's a little bit clearer there. I have a glare. So again, everything on this line is a solution to that equation. And when I'm asked to solve a system of equations, so solve each system graphically, what I'm looking for is what ordered pair will work in both of them. And the ordered pair that will work in both of them is this point right here. This point is a solution to this equation, and this point is a solution to this equation. So the point of intersection is our solution to both. What is that point? Well, we've got 1, 2, 3. And then we go up 2. 3, 2. We're saying that 3, 2, the ordered pair 3, 2 works in both of those. Let's check just to make sure. So we're going to put 3 in for x and 2 in for y in the top equation. 3 plus 2 is 5. Then we're going to put this into the next equation. 3 minus 2 is 1. So it works in both. You found a solution to the system, the two equations. All right, let's try another one. We have a few here to practice. Looking at this one, this is similar. This is a kind of a copy of your homework. Let's see. Okay. Well, we need to graph x equals a -1, and we need to graph y equals 2. Well, because they're both missing a certain variable, we know that they'll either be a perfectly horizontal line or a vertical line, since we're missing a variable. Well, let's look at the first one, x equals a -1. What that tells us is that x will be a -1 and y can be anything. This is going to be a vertical line. Okay, so here, talk us through this one. This will be a vertical line. It'll hit the x-axis at a -1. So as long as x is, a -1, I almost went to the +1. So we have like a -1, 0. X is a -1, 1. See, the y can be anything. So this is going to hit the x-axis at a -1. So it's a vertical line through a -1. So you can either plot points or just know that x equals is going to hit the x-axis wherever it equals. X equals a -1. I got most of the points. Connecting a lot. So we have a vertical line. And just as a review, the slope of this vertical line. The slope of this vertical line is undefined. Right? And the reason is because if you were to take the difference in the y's over the difference in the x's, you're going to get like some number over 0 when you take the difference in the y's over the difference in the x's. So it's going to be undefined. All right, so let's look at our next one. Enough of a review of the slope here. Y equals 2. Y equals 2 is a horizontal, which means here that x can be anything. It's not in the equation, so you can make it anything you want when you have your ordered pairs, but the y has to stay 0. So it's 1, 2, 2, 2, 3, 2. And if you plot these points, you end up with a horizontal line. So it's going to hit the y-axis at 2. Make sure I'm y equals 2, because I almost did that other one at 1. So the -1. All right. So what we have here then are two equations that are graphed. What ordered pair works in both of them? And that would be the intersection point. And the intersection point is going to be a -1, 2. That's our intersection point. -1, 2. That's a solution to the system. Some of the wording. The solution of the system is -1, 2. All right, so if I put this into this top equation, the y is missing, so we don't care. So we just put the x in. -1 equals a -1. Is it a solution for this one? Well, there's no x, so we can't put it in, but we can put the 2 in for y, 2 equals 2. So it does work. So that's a solution to the system. So it's just a great review of graphing, and then you just look for the common point. Will they always have a common point? Let's see. Let's look at another one. Okay. This one right here. Okay. Sorry, I just want to get this little situated here so I don't have lumps in my papers. Okay. Hold this. All right, here we go, finally. All right, I'm going to graph these two equations. Well, the first one, you can see it. You can see it now. This would be your number 4 on your assignment. To graph this one, it's y equals mx plus b. So we're not going to use the x and y intercept method. We're going to use the point slope method, which means that this is the y-intercept, all right? This is the y-intercept where it hits the y-axis, because if it hits the y-axis when x is 0. All right, so when x is 0, the y-intercept is 6, because that's gone. When x is 0, that whole term cancels out. So we know we have y equals mx plus b. Here, let me put that up here. There's so many things to remember, which means we'll go to 6 on the y-axis, which is right here. And from there, the slope is a negative 1/3. That means that we're going to go, this is rise over run. We'll go down 1 instead of up. The reason I'm going to go down is because it's negative. Down and to the right. So we'll go down 1 to the 5 and to the right 3. 1, 2, 3. And there's my other point, and MyMathLab will connect them for you. And again, don't press save until after you graph the other one. Oh, I hope that my graphs are all right. I'm going to make sure. Okay, go down 1 and to the right 3. Yes, good job. Kind of missed the lines a little bit. All right, what about that next one? Wow. You know, it's not really in the form that we were using for the x and y intercept, where we had the x's and y's on one side, and the y is not by itself. So what I think I'm going to do is I'm going to go ahead and I'm going to make this look like this, because it's close. This is really close to looking like this. All I have to do is get rid of that 3. How? It's 3 times y. So what I'll do is I'll divide every term by 3. You can do that as long as you do that to every term. And then that way the y is by itself. It looks like this, and we'll use the method we used here. So we've got, I'm going to copy it over, and then we're going to get that y by itself so we can use this slope intercept method. Divide by 3, divide by 3, divide by 3. Looks good. Those cancel out. So we have 1y, which is what we want. Y equals, what about this x over 3? Well, you have to remember that if there's not a number in front of the x, right here, it's a 1. So to write it so it looks like this, I'm going to write this as 1/3 x. So I can see my slope. You know, it's not that this is wrong, but to graph, this is right, but to graph, I like to have this out front, in front of the x. And because this is a 1, I just write 1/3 x plus 12 divided by 3 is 4. So now it looks like this. So we'll use that slope intercept method. Intercept meaning the y-intercept. Okay, I'm going to go up to 4. All right, so here I'm going to go to 4 on the y-axis. That's my y-intercept. My slope, ooh, it's positive. So rather than going here, I went down 1 and to the right 3. I'm going to go up 1 and to the right 3. Up 1, 1, 2, 3. Oh, yay. Happened to be that ended on that same point. Awesome. And again, make sure you graph both of those lines before you press save. So what solution works in both of them? Here are the solutions for the bottom equation here. These are the solutions for the top. What solution works in both of them is the intersection point, which happens to be 1, 2, 3, and then 1, 2, 3, 4, 5, 3, 5. Okay, 3, 5. So our solution is 3, 5, and you could check that. The top one, -1/3 times 3. Wow, here we go. Review of how to multiply fractions. How do you take -1/3 times 3? And we put our whole numbers over 1 and add 6. Do you get 5? Does that equal 5? Well, these cancel. You reduce before you multiply across. So we end up with a -1 plus 5, -1 over 1, -1. Oh, sorry, plus 6. I said the answer. I was doing the answer in my head, which is equal to 5, which is what the y is, which is what we wanted our y to be. So that it works in that one. This one right here, you're going to put 3 in for x. 3 plus 12 is 15. 3y is 5. 3 times 5 is 15. So it works in both of those. So again, you're graphing and looking for the common point. All right. Let's try another one. Ooh. It didn't look like it here. This, I'm pretty sure that this should be an equal sign. Okay, we're going to make that an equal sign. Now, I must be my printer must need to be cleaned. Okay, let's go ahead and graph these and see what we've got. Method. All right, well, you could plot some points. You could say, okay, listen, what happens if the x is 0? What's the y? Maybe x is 2. You can pick some points for the x's and put them in and see what the y's are and plot them. But I'm going to go ahead and use the x and y intercept method. And the reason why, and again, I know I keep going over this, but you need to see something, like I said earlier, about 32 times before you can remember it. It's just that these numbers in front go into here evenly. 3 goes into 6 and a -1 goes into 6, which makes it a prime candidate for the x and y intercept. Oh, the other one doesn't look quite as pretty. Even though I know that I'm pretty sure that's supposed to be a 6. I may have to look at that real quick and double check to make sure. All right, this one, in this example, and I looked at some of the other examples real quick, and then now I'm back. It's just that when we're going to graph this first one using the x and y intercept, because you can take 6 divided by 3, and you can take 6 divided by a -1, and you get whole numbers, so you're able to graph those easily. On the second one, though, 6 divided by 9 is a fraction. You can take 6 divided by a -3. So we're going to do this one a little bit differently, but I think on yours, when you do your homework, I think you'll be able to divide this by both of them, and you'll be able to use this method. But just in case, I'm glad you know that this happened with this example so that we can go through what happens if the y is not by itself and you can't take this divided by one of these, and in this case it's this one. So 6 divided by 9 actually is 2/3. You reduce it. It's hard to plot 2/3. All right, so let's go ahead and do our first one. We're going to use the x and y intercept method because you can take 6 divided by 3 and 6 divided by a -1. So we're going to find the y intercept by making the x 0. So we'll have 3 times 0. Is that clear? Yeah, you can see it. Minus y equals 6. So to find the y intercept, you make the x 0. Divide by a -1 to get that y by itself. So this line is going to hit the y-axis at a -6. So we'll go to -6. Put a graph, put a point there. All righty, move it up maybe slightly. Now to find, okay, that's the y-intercept. We made the x 0. To find the x-intercept, we'll make the y 0. It's gone. Divide by 3. So this top line, it hits the y-axis at a -6 and the x-axis at 2. And we'll graph it. Okay. You know, and I'm kind of glad this next one we can't use the x and y intercept, because I wanted to talk about how to get the y by itself. So looking at this next one, what I'm going to do to graph this is I'm going to make it a y equals, and then we can use the slope intercept method. When you're asked to get the y by itself, and when we graph inequalities, or when you're in your other classes and you have to graph an inequality, you need the skill of getting the y by itself. To do that, we always get rid of what's being added or subtracted first. So we're going to, these are just 2 steps. All of these are just 2 steps here. Sometimes they're just 1, but in this case, it's going to take 2. I need to get the y by itself, so I'm going to get rid of this first by adding the opposite. So that just leaves me with a -3y. On the right-hand side, you have an option here. You can take the 6 and then write -9x. But one thing you cannot do is to combine that 6 and that 9. And the reason is this 6 does not have an x. So this -9x and that 6 have to stay separate. Well, if we want to be able to match this idea, so we can graph it, I'm going to put the x first. And then the +6. Okay, I like having that x first. You know, is it wrong if you would have gone 6 minus 9x? No, it's not. It's just sometimes because we don't have that x first, it's kind of hard to identify the slope, but it's not wrong. All right, so we subtracted 9x from both sides. Awesome. Now we still want the y by itself. Got to have a 1y. So I'm going to divide every term by a -3. All right. So now we have a +1, because a negative over a negative is a positive, and the 3's canceled. -9 divided by a -3, it's a negative over a negative, so it's going to be a positive because we have 2 negatives. It's even, so it's going to be a positive 3x. 9 divided by 3 is 3. And you still have the x. Whoa, it's not going to be a plus, is it? Because 6 divided by a -3 is a -2. All right. So I'm going to graph this. It's the same as this. It just looks different. And this is in the form that we like for graphing. This is in a form we like. So again, if you can always take any equation and get the y by itself and use this form. Slope intercept, now you know what the y-intercept is, and you know what the slope is. You can't really tell what the y-intercept and the slope are by looking at that, but you can tell what the y-intercept or the slope are by looking at this. So we're going to graph this line over here. Let me scooch it over. So we're going to go to a -2 on the y-axis. And we're going to go, if this is 3 over 1. So if you have a whole number, put it over 1 so you have a slope to do. Rise over run, up 3 over 1. So we'll go up 3, 1, 2, 3, and over 1. Ooh, wow. Look at this. What happened? If we connect these dots up, these lines do not intersect. there's no solution. And what happened is that if you look at the slope of these lines, the slope of these lines are both 3. You go up 3 over 1, up 3 over 1. So they're both 3 over 1. Lines that have the same slope are parallel lines, and they won't intersect. So looking at this, if you end up with parallel lines, the system has no solution. The system has no solution. Okay, all right. Let me look at the next one. Hopefully we have another one to graph. Yes, we do. So we're going to graph this one right here. And see what happens. So blank sheet here. The first one, it might look a little confusing to graph when you first look at it. But all I'm going to do is I'm going to take that negative x and put it in front of the 6 so that it matches our y equals mx plus b. So I'm going to see, I like having that x turn in front. So I'm going to put the negative x. So the negative stays in front, so it's a negative x, which means we have a -1 slope. And then the 6 is positive, so it's +6. So I'm just going to kind of swap those two. They mean the same thing. That kind of looks like a B, doesn't it? Let me go make it a 6. Okay, we're going to go to a 6 on the y. The y-intercept is 6. So we're going to go to on 6. And then you're going to go, the slope is a -1. So our slope is a -1, but we put our whole numbers over 1 so that we have that ratio of rise over run. But if we find this, to go back to here, we drop the 1. To graph it, we put the 1 back in. So we'll go down 1 because it's negative, and to the right 1. And connect up our dots. Let me see, down 1 over 1. Each line is 1. Okay. All right. I just have to double check. There. All right, so that's that line right there. I wanted to make sure I had everything connected correctly. I'm a little off, but it's not bad. All right, let's graph the next one. Well, do we want to get the y by itself? We could subtract the 5x and then divide by 5. But you can take 30 divided by 5. You can take 30 divided by 5. So let's use the intercept. To find the x-intercept, excuse me, let's find the y. We always find the y first. I don't know why, but let's find the y-intercept. And to do that, you make the x 0. So that's gone. So 5y equals 30, divide by 5. Starting to skip some steps here, sorry. Y is 6. It's going to, oh, same. It's going to hit at the same spot as our other one did. Same point. Now let's go ahead and find the where the x-intercept. So to find the x-intercept where it hits the x-axis, you make the y 0. And 5x equals, because that's gone. Divide by 5, divide by 5. X equals 6. It's going to hit the x-axis at 6, which is the same as the other one. So an interesting thing happens, that when I connect these dots, I end up with the same line. So what does that mean when I want to know what point works in both of them? Well, it looks like any point on one line is going to work in the other one, no matter what. All of these points work in both equations, and there's an infinite number of them. So this is the same line, which means that you have an infinite number of solutions. So let's look at our choices. The solution of the system is one of them. No. There are infinitely many solutions. The solution set is, this is red, the set of all x and y's ordered pair, such that bar means such that y is equal to this. So they're saying that any ordered pair works as long as it works in one of them. They chose to use this one. You could have used another one. So there's our solution. So there are times when you have an infinite number, that's when you have the same line, or going back to the one we just rats. Where is that? Or if they're parallel, there's no solution. And there are times when we have one solution. So one, none, they're parallel, they don't intersect at all. Or maybe they're the same line, so you have an infinite number of points that'll work in both equations. All right, so graphically, that's your idea. Now, obviously, graphing isn't probably the best way, because what happens if the intersection is a fraction? How are you going to tell if it's 1/16 using the graphing method? So we need some algebraic methods to solve these, and that's what we're going to look at next. And there's only two of them. One is called substitution, and it's an important one to know. And the other one is called the elimination. So we're going to talk about the substitution method first. We're not going to graph them. We're going to find the solution algebraically. Okay, so let's look at this using the substitution method. To use this method, you've got these two equations. And the substitution method works great if one of the equations has one of the variables by itself. That's really a key to using this method, other than the fact that they're going to tell you use substitution. But you don't have to use the method they tell you. So don't feel bound for that. But this one is set up perfectly for the substitution method. So here, I'm gonna write this over here. I have my two equations. What I'm going to do is, I know that the x's and the y's match. Whenever they intersect, those x's and y's are the same. So I am going to take this y is equal to this. I'm going to put this right there. And I'm going to substitute x plus 1 in for the y, because it's equal. They're equal. So that means I can just substitute it in. So this equation right here is going to become, you have your x still, but instead of the y, I'm going to write x plus 1, because the y and the x plus 1 are equal to each other. So instead of the y, I'm going to write x plus 1. And I still have the 3. That's called substitution. This, I substituted this in for the y because they're equal. And now you solve it for the x. So here, how do you solve this for the x? Great review on solving equations. This becomes 2x. X plus x is 2x. So then we subtract 1. So we want the x by itself. And then we divide by 2. So there's my x coordinate. It's 1. But remember that the intersection is an ordered pair. And some students stop here. MyMathLab won't let you stop here. You'll need to finish it. But on the test, make sure that you do find the ordered pair. Well, how do you do that? Well, I know that x is 1. What's the y? I'd put it right here. Put the 1 right here and see what y is. So substituting that back in, I have y equals 1 plus 1. y is 2. So this is the intersection point of those two lines. Make sure it works in both of them. We know it works in this one, but here 1 plus 2 is 3. So the answer is 1, 2. That's the substitution. And I have about 3 of those to go through with you. Hopefully you'll understand this method of finding the point of intersection. All right. Let's look at this number 8 and go through it. Again, it's a prime candidate for the substitution method because one of the equations has one of the variables by itself. The top equation has the x by itself, which makes it a prime candidate for the substitution method. I'm going to copy these over here. X plus 2y. Okay, I know what the x is equal to. X is equal to this. Because x is equal to this x, I'm going to swap these two. Okay, I'm going to substitute this in right there. Since x is equal to that, I'm going to put it right there. So instead of that x, I'm going to write y plus 1 plus 2y equals 13. All righty. So I'm substituting whatever this variable is. So in this case, it's an x is equal to that. The x will become that in the other equation. And now you solve it. You finish it up. Well, when we have an equation, we always try to simplify this side or one of the sides both first. Nothing to do over there. But here, 2y and 1y is 3y. So I always try to simplify before you start to move things from left to right. So now that we have both the left and the right simplified, I need to get the y by itself. So I'm going to go ahead and subtract the 1. Oh, these are nice whole numbers. And then divide by 3. Y equals 4. Oh, let me move that up a little bit, sorry. So the y is equal to 4 in this one. I want to make sure I have the question on here. There. Y is equal to 4. We now need to know what the x is because our answer is an ordered pair. The point of intersection is an ordered pair, which means I'm going to go back to this top one. This is the easiest one to find out what x is equal to. So x is equal to y plus 1, and the y is a 4. I found that out. X equals 5. 4 plus 1 is 5. So I know that the point of intersection is x goes first, always alphabetical. That's the point of intersection, 5, 4. You can put those in. So if I were to put in 5 here, 5 is equal to 4 plus 1. Yeah, it is. Here, 5, this one's a little bit, let me see, 5 plus 2 times, what's the y? 4? Does that equal 13? 5 plus 8 is 13. So it works. So that's a solution to both of those. All righty. Okay, let's try another one on our substitution method. Yeah, this one's a little bit more complicated, but it's not much. And this will be the last one we do for substitution. We'll look at the elimination method. Again, this is a prime candidate for the substitution method because one of the equations has one of the variables by itself. So I'm going to take this here. y is equal to that. So in the other equation, I'm going to make the y 3x minus 1. The problem is that 2. What do you do with that 2 in front of the y? Well, here you would go 2, and you have to have parentheses. You put what the y is now. That's how that's written, 2y. You do have to have the parentheses. That's how that's handled. So you will be using the distributive property here. So this is 2y, okay, minus the x equals 3. Okay. So I substituted in, this goes right there. And because of that number out front, I'm going to use parentheses, and which means I'll be using the distributive property here. Okay, to solve it, we're going to multiply this through first. So we get 6x minus 2. We're still working on that left of the side of the equation. Combining like terms, 6x and a minus 1x is 5x. Okay. And that's all I can do as far as simplifying. Now I can start to move stuff, now that I kind of combine my like terms. And let's get rid of the 2 plus 2. Get rid of what's being added first. So we have 5x equals 5. Oh, nice numbers. Divide by 5. X equals 1. Okay. So our x is 1. But what's the y? Because we want the ordered pair. So I'm going to take the 1 and I'm going to put it back up into this one. Just a little bit easier, the one that has the variable by itself. So the x is a 1. I'll substitute that in. Since it's equal, 3 times 1 is 3. All right. So my point of intersection is 1, 2. There's your point of intersection. So that wasn't too bad. And you could try it. If you were to put in 1 for the x, 3 times 1 is 3 minus 1 is 2. So it works. If you were to put in 2 times y is 2. So 2 times 2 minus 1, x is 1. Does that equal 3? Does 4 minus 1 equal 3? Sure it does. So they both work. So there's your point of intersection. It works in both of them. So that's all I have for the substitution. We're going to do the elimination, and I've got quite a few examples for the elimination, but I'm hoping that you understand the substitution method. And again, if you substitute it in and there's a number in front, you'll need to use the parentheses and distributive property every time. So kind of keep that in mind. All right, so now what we're going to look at is we're going to look at the elimination method, our last method here. All right, so looking at your homework, number 10, we're going to be using the elimination method. And they'll tell you to use the elimination method, but if they didn't tell you, they said, okay, choose a method, substitution or elimination. Here, if you look at these equations right here, neither one of these have a variable by itself, like we did in the last 3, where we had like y equals or x equals. So these right here are prime and set up for what's called the elimination method. See how the A's line up in the equations, and then the B's, and we have the equal sign, and then we have the 16. I really need to clean my printer. It's not printing well, but it'll work. So what we have is we have 2A plus 7B equals 16. And we have a minus 2A plus 1B equals 16. Okay, what we're going to do is we're going to add these equations together. And when we add these together, notice that we have one of the variables, the numbers in front are equal and opposite. And when I add these together, they'll drop out. So if you look at the A's, this is a 2 and a negative 2. So if I do add these equations, those are going to drop out. And I'm just going to end up with b's. So I'll have 8b equals 32. I'm adding and I'm adding. And you solve it for b. And then you just have to substitute it back in to find the a. So again, these right here were equal and opposite. We're going to go through somewhere what happens if they're not equal and opposite. None of them are equal and opposite. It's just one simple step to make them. But here to finish it, so we just added them together. And again, we're finding a number that works in both. Divide by 8, so b then is equal to 4. But it's an ordered pair. And if you have the b, you need to find the a. How do you find the a? Well, you put the b back up into either this equation or this equation, substitute it in, and solve it for a. Because this has that 7, which will make the numbers bigger, I'm going to use this one, even though it has the negative. So you pick one of them, doesn't matter. Whichever one you think the numbers look nice to work with. And I'm going to put the 4 in right there. So I picked one. Now that I know what the b is, I'll put it in and solve it for a. We're finding our common intersection. Solve it for a. And on this one, like substitution, there are times when we had to simplify that left side, but here we don't have to. We just have to move things and get the a by itself. Equals 12. Sure I have that right. Divide by a -2, divide by a -2. A is equal to, because we wanted to get rid of that -2, so we divide by a -2. -2 over a -2 is a +1, -6. Now, when you write these as an ordered pair, you put them in alphabetical order when you write the solution. So our solution is a -6, 4. And to check those, you would put a -6 in, you would put 4 in, and make sure you get 16. So you get -12 plus 28, 7 times 4 is 28, -12 plus 28 is 16. So it works in the other equation that I didn't use here. Okay, so there's my common intersection, -6, 4. That point works in both of them, and you can use these quite a bit for story problems, but we're not going to do. Where are we? Okay, let's look at this one. Again, solve using the elimination. Why would they tell you to use the elimination and not the substitution? Neither one of these have a variable by itself. So the x is not by itself, the y is not by itself, but they do line up. Got your x's, your y's, and then your constants out here. And we have a +6y and a -6y. So that when I add these together, these two add up to 0. 6 and a -6 is 0. So you're eliminating, just the name, the y's. And sometimes you'll eliminate the x's, sometimes you'll eliminate the a's, the b's. One of them should drop out, which gives us, now we have 5x plus 7x is 12x equals -34, and a +22 is a -12 when you add those together. 22 of these are going to take care of 22 of those, and you'll have 12 negatives left. So then we divide by 12. I try not to make the numbers too awful. So I know that my x is a -1. But you have to have an ordered pair. So I now know what the x is, but I don't know what the y is. How do you find the y? You pick one of these. You can either use the first equation or the second equation. I like to work with positives, so I'm going to use the first equation. and I'm going to put this back in and solve it for the y. So I'm going to use the top equation, and it doesn't matter because the point is on both of them. All right, so I'm going to put this right here, okay, because x is a -1, and I chose the top equation to substitute it back into. And so the elimination method, you're eliminating one of the variables when you add, and then solve it. So here, put a -1. 5 times a -1 is a -6. Oops, really? It's a -5. I was looking at that 6. -5 plus 6y equals 22. Okay. Add 5. Okay. So now we're solving it for y. We need to know what the y is. We know what the x is. Now we need to know what the y coordinate is. So we come up with 6y. Oh, I'm gonna make sure that I copy that right, because I didn't really want to have a fraction. It doesn't mean we won't have a fraction. It looks like we're going to have a fraction, but that's okay. 27. And then we divide by 6. Y is equal to. Now the problem is I'm going to leave it as a fraction, but it has to be reduced. So 3 goes into both of these. So I'm going to divide them both by 3. 27 divided by 3 is 9. How did I know that 3 goes into here? Because 2 plus 7 is 9. 3 goes into 9, so 3 goes into that. All right, so 3 goes into there 9 times, 3 goes into there twice. And it tells you to use a simplified fraction here, an integer, a simplified fraction. So don't make it a mixed number. Leave it as 9/2. So my point of intersection is a -1 9/2. All right, I have a bunch of these to try. So let's try another one. I'm going to skip 12 right now, and I'll come back to it. It's kind of a special case. That's why I circled it. I wanted, well, let's go ahead. You know, let's go ahead and try it. Okay. Now, we want to, we're going to use the elimination method because they tell us to, but also because of the way it's written and how it's presented. We've got the x's in a row, the y's in a row, and then the numbers, and none of these variables are by themselves. All right, so we're going to take these and we're going to add them together. Well, I'm going to copy this over real quick. It won't take me long. Okay, so here when I add these together, 9x and a -9x is 0. -7y and a +7y, they also drop out. There's nothing there. Equals, okay, I guess we have our plus or whatever. 0 is neither positive or negative, so it doesn't matter. We'll put a plus. 1 plus a -1 is 0. There's no variables. What does this mean? 0 equals 0. Well, is that a true statement? Does 0 equal 0? Yeah, it does. But then, you know, exactly what does that mean? What's happened? Well, if you remember when we were graphing, oh, I hope I have that graph. I thought I'd set it aside here. Ah, I did. We had 2 special cases. One time, the lines were the same line, and so we had an infinite number of solutions. Here, they were parallel, they were separate, parallel, they never intersected. This was a no solution, an infinite number solution. Well, if the variables drop out and your statement is true, Does 0 equal 0? Yes, it does. You have this case, an infinite number of solutions. So if this is true, you've got this one where they're the same line. If you were to graph these, you would get the same line. So your answer here, when the variables drop out, you'll have two choices, infinite number or no solution. If it's true, it's an infinite number of solutions. And MyMathLab will give you that choice, which is kind of nice. The solution set is the set of all x's. It's an infinite number such that they fit this line. So it would be 12. And they didn't put the word infinite, which I'm kind of disappointed. You know, I get the star means I got it from another book, but I think you'll understand that that would be an infinite number of solutions. Well, what happens? Let's look at another one here. Let's just go ahead and do our other little case scenario here. Okay, let's look at number 15. What happens here? Well, on number 15, we have to do something. And that's all right. We can do this. On number 15, we have a negative 9x This will have a little extra step. We're going to cover a couple of little ideas here. You know, if you added these together, the x's will not drop out and the y's will not drop out. So what do? You have, one of those is going to have to drop out. So you have to pick one. Do you want the x's to drop out or do you want the y's to drop out? And once you've decided, let's say I want the x's to drop out. That means that number has to be a positive 9. How can I make a 3 a positive 9? I could multiply everything by 3. That would create the positive 9 that I need. So you look and you think, okay, what variable do I want to drop out? And it, you know, it doesn't matter. You could make the y's drop out or the x's drop out. I chose the x's, so I had to make this a positive 9. And you always multiply. What do you multiply by to make that a positive 9? Well, 3. The problem is you have to multiply everything by the 3. And people forget that. You've got to multiply that by the 3. So the top equation is going to stay. And we're going to practice this idea in some other problems. This is 3 times 3 is 9x. 3 times 2 is 6y. 3 times 3 is 9. Now these will drop out. But what happens? Well, these drop out. Oh, and there's nothing left. These drop out. So those are 0. Those are 0. Equals, there's no variables. And over here, we come up with 22. Yeah, 722. Okay. Does 0 equal 22? No, it doesn't. So what this means is that your solutions, if it's a false statement, rather than being if it's true, it's infinite, but here it's false. So that means they're parallel lines, which means there's no solution. There is no solution because that's false. It's false, so there's no solution. It means the lines are parallel if you graphed them. Okay, so those are only 2 special cases. So let's go ahead. Let's keep practicing our elimination method. Ooh, let's look at number 13. Here, what have we got? All right, let's stretch a piece of paper. I'm going to use the elimination method. Okay, I'm going to copy it over. And 5x. Wow. If I add them together, the x's do not drop out. If I add the y's, I get a -2. The y's don't drop out. So this is just like the previous problem. We're going to practice this. You have to pick a variable and you have to decide, okay, do you want the y's to drop out? And if so, they have to be equal and opposite. You're going to have to multiply one of them by something. Do you want the x's to drop out? And if that's true, then what are you going to multiply by so that the x's drop out? And it doesn't matter which one. If you want the y's to drop out, you'll have to multiply one of the equations by a -1. Doesn't matter which equation, but one of them by a -1, because that's got to be a positive so that they add up to 0. If you want the x's to drop out, you'll have to multiply the top equation by 5, because that'll give you a -5 and a +5. So whether or not you'll get the same answer no matter what variable. Some are just easier. You know, I'm not sure what you guys would do if you would multiply by a -1, or would just to make the y's drop out, or multiply by a 5. I'm thinking you may have chosen to multiply that by a 5. That may have been more obvious to you. 5, and then that'll make a -5. Even though you'll be dealing with some larger numbers. We'll go ahead and go with the 5. So I'm going to multiply this equation by 5. So 5 times a -1 is a -5x. 5 times a -1y is a -5y. And then don't forget 5 times the 3. That guy gets forgotten a lot. Then I'm not going to do anything with this bottom one. All right. So, you know, I just kind of made it look different. I haven't really changed the values and things like that. I just made it look different. And now the x's drop out. So here, those will drop out, and I'll end up with a -6y. -5 and a -1 is a -6y. Oh, great. I'm glad this comes out to be a whole number. You get 12. 15 and -3 is 12. All right, so I just created an equation so that the x's dropped. Divide by a -6. Y is equal to a -2. Now you have to find the x. Now that you know what y is, you have to find the x. You're going to put this back up into one of these equations, and you're thinking, well, which one? Well, it doesn't matter, because the point is the same, because it's an intersection. So whether or not you put it in this line or this line, it's the same point. So we can put it up into this original. The numbers are smaller, but there's a lot of negatives here. You can put the y here. There aren't as many negatives, but the numbers are a little bit bigger. Let's put it up into the top one. Let's just put it up there. So we have a -x. You know, you could have put it into this one too. That one, it doesn't matter. So I'm going to put this right here, right there. There's a problem with the 2 negatives, but I think you guys will be fine. The y is a -2. So you still have that. There's your y. So a -x plus 2. All right. And you subtract 2. We want to get the y by itself. And again, the 2 negatives is a positive. So a -x equals 1. The numbers aren't big, but there are some little places where you could make some mistakes. Divide by a -1. So my point of intersection is a -1, -2. Okay. All right. That's great. Let's look at another one real quick. All right, we're going to look at another one, and this will probably be the last one we look at. It's, you know, it's one of the, you only have a couple of these where you're going to have to multiply by something in order to make one of the variables drop out. So for the most part, they'll be pretty simple. Just a couple of these. There aren't too many problems on this assignment. So here we've got X. And here we have X minus Y. Okay, you're going to have to decide if you want the X's to drop out or the Y's. You know, looking at this, I think I'm going to have the X's drop out because they're equal, but they're not opposite. How do you make them opposite? Well, multiply one of those by a -1. And that will change the sign on everything. And so I think what I'm going to do is I'm going to multiply this bottom one by a -1. I'm going to leave the top one alone. And this is going to create the X's as being equal and opposite, so they drop out. -1 times X is a -X. Yay, they're equal and opposite, they'll drop out. -1 times a -Y is a positive Y. And a -1 times a -1 is a positive 1. Okay. So when I use the elimination, these are eliminated when I add these two equations together. So I end up with 7y equals 14. Perfect. Divide by 7, y equals 2. But now I need to find out what x is equal to. So, you know, I think I'm going to use that top equation here to see what x is. I'm going to make the y a 2, just so I don't have to deal with negatives. Not that negatives are bad. Well, I guess you could put 2 in here and it wouldn't be too bad. All right, let's do this original. X minus y equals a -1. That was the second original one. So I'm going to put this right here. And well, that wasn't so bad. Add 2. X equals 1. 1, 2. We'll work in both of those equations. Okay. All right. So that again, the elimination method, most of the time they'll be equal. Something will be equal and opposite. If not, you have to multiply to make one of the variables equal and opposite. All right. So we're done with that. Those 3 methods, graphing to solve a system, or substitution, or the elimination. All right, just all depends on how it's presented to you. All right, well, let me know if you're struggling. Okay, bye-bye.